In this video, we solve problem 100 from section 5.2, not 5.3, from the Larson Calculus textbook 10th edition. We're told that the demand equation for a product is P of X equals 90,000 divided by 400 plus 3X, where P is the price in dollars and X is the number of units in thousands. We're asked to find the average price on the interval from 40, X equals 40 to X equals 50. The formula for the average value of a function is relatively simple. And the average value on the interval from a to b is 1 divided by b minus a times the integral from a to b of f of x dx. So geometrically, if we're looking at the integral from a to b of f of x dx, we're talking about the area between that function and the x-axis, starting at x equals a and x equals b. On that interval, the y values are going to take on a continuum of values. So all of the y values from its minimum value on the interval to its maximum value on the interval are covered on that interval from x equals a to x equals b. So you'd say, okay, well, if I've got a continuum of values for my y values on the graph, how do I find the average? Well, what we do is we just take the area under the curve and we divide by the length of the interval to get an average height. So that this is the area divided by the length to get the average height. And so the average height is going to be something like this. There's going to be some x value on the interval where that function is equal to its average as well. And we're going to be able to draw the area of a rectangle, and the area of that rectangle will be the same as the area under the curve. So now we're doing that for a particular application problem. We're asked to find the average price, so the average of this function on the interval from 40 to 50. So P average is just 1 divided by 50 minus 40 times the integral from 40 to 50 of that demand equation, which is just the price of the product when X is the number of units available, I think. Okay, so in order to evaluate that, we need to evaluate the integral, and then we'll just divide the answer by 10 in order to get P average. Now, when I look at this integral from 40 to 50 of this function, of course, I always ask myself, do I have a rule for that? And the answer is no, we don't have a rule right now, but we could have a rule if we let u equal the denominator. We can use u substitution if we write this integral entirely in terms of u, and we'll be able to evaluate it. So we let u equal the denominator, and then we compute du. That's the derivative of this with respect to x, which is 3, times dx. And we say, do we have a 3 dx as a factor up there? We don't have a 3 dx, but we have a 90,000 dx. So I guess I could multiply both sides of this by 30,000. So 30,000 du turns out to be 90,000 dx. That 90,000 dx can now be replaced by 30,000 du. And our integral can be written as this 90,000 dx replaced by that 30,000 du. So we have 30,000 in the numerator divided by 400 plus 3x, which is actually our u. And now we need new bounds for u. So in order to find the bounds for u, we substitute the bounds for x into this equation. So we evaluate u at x equals 50, and we evaluate u at x equals 40, and then we simplify. At x equals 50, we get 150 plus 400, which is 550. That's our upper bound for u. And at x equals 40, we've got 400 plus 3 times 40. So 120 plus 400 is 520. So we're just going to evaluate this function, or compute the antiderivative, and then evaluate from 520 to 550. So to do that, we take the antiderivative first by the fundamental theorem of calculus. Very easy to do. So we have 30,000 times natural log of the absolute value of u, and then we evaluate at u equals 520 and u equals 550, and then we subtract. So if I factor out that 30,000, I've got natural log of 550. The absolute value of 550 is 550 minus the natural log of 520. And if you want, you can write that as natural log of the quotient. Natural log of A minus natural log of B is natural log of A over B. So you can write that as 550 divided by 520 if you want to. And then just simplify. And then we'll find out what that value is. And we'll use a calculator for that. That is the value of the integral of that price function. And then we'll divide by that 10 in order to get the average price. We divide this number by 10, our P average is going to be 3,000 times the natural log of 550 divided by 520, whatever that is. So use our calculator to compute those two numbers, and we'll also visualize this on Desmos. So this is our price or our demand equation. So that's giving us the price with at the various numbers of units available. X is the number of units in thousands, and P is the price in dollars. So I believe it's a number of units available. So when our number of units available is actually 40,000, the price in dollars of this product is $173.08. And then when there are 50,000 units available, the price goes down. And so the price is $163.64 approximately. We say, okay, well, what is the average price on that interval when we're going from 40,000 units available to 50,000 units available? Well, we find the area under the curve by evaluating the integral. And then we divide by 10, divide by the length of the interval to get that price, that average price. Now, Desmos.com will do that integration for us. It tells us that the value of the integral is 1,682.68 approximately. And then if I divide by 10, I get an average price of $168.27. But we might want to use a fundamental theorem of calculus. So we did a u substitution. We said, let's write the integral in terms of u instead. We're going to evaluate this integral. Actually, let me write it down. We're going to let u equal that denominator, 400 plus 3x. Then du is 3 times dx. And then if we multiply both sides by 30,000, we get 30,000 du equals 90,000 dx. So we end up with 1 divided by u as our integrand. And then we've got that 90,000 dx, which becomes a 30,000 du. So you can put a 30,000 in that numerator. So you have 30,000 divided by u du as our integrand now. And then we integrate from one u value to another. To find those u values, we can think of this u as a function of x, and then evaluate at x equals 40, and evaluate at x equals 50. And so we see that when x equals 40, u is equals 520. So that was our 40 was our original upper or lower bound. So 520 is our next lower bound, our lower bound in terms of u. And then x equals 50 was our original upper bound. U at x equals 50 is 550. So our new upper bound is at 550. So we compute the antiderivative using just our basic rules. So we're going to get 30,000 times natural log of the absolute value of u Okay, it's not letting me use u there. I'm going to call this u sub 1 instead. And then we'll evaluate that function at 550 and 520 and subtract. And let's see, we get the same value that Desmos got from evaluating that integral. So we get that 1,682.68 approximately. And so that's a price times a differential in units. And then you add them together. So I'm not really sure how I would interpret that integral just as it stands. But when I divide by that interval, the number of units, that 10,000, that change in the number of units from 40,000 to 50,000 units, then we know that that's actually an average price. So we're going to take the value of the integral and divide by 10, and we get that $168.27 is the average price. Now we can visualize that. P average is given by that Y value right there. We graph a rectangle. We see that the area of that rectangle with the average price as its height. Kind of want to get rid of those ordered pairs now. The area of that rectangle, the green rectangle, is the same as that original area under the curve. So that area is equal to this area. So what we'll say is, what was the question? Find the average price. Make sure you answer the question. The average price P on the interval from 40 to 50 for X is $168.27.